So I'll be talking about Flutter application. As Romet already mentioned, I can't bring you a surprise what I worked on, but well, it was the big bank application. For me, a second banking application that I've been working on, but actually first production application in Flutter. One big thing about it is that we managed to deliver it into production within 5 months and actually kept on working on it. A little overview of what I'll be talking about. I'll give a quick introduction about myself. Fortunately, I don't have to talk about Mooncascade too much now because Romet already took care of that. And I'll then talk about the mystery application, which is no longer the mystery, and give you some technical details with architecture and approaches, and then also some design system implementation suggestions or advice. So introduction about myself. Who am I? I'm Oliver Vainumäe. You can just forget the second name or the last name. It might be complicated. Even Estonians get confused with that. But I am an Android developer, specifically Android developer. I don't do any iOS development. We have Ilke for that. And yeah, I picked up Flutter around 2022, which is when in the company we decided to have, since a lot of people were not without the project, an active project, we decided to have some learning experience. A lot of people picked it up and we decided to have some sort of internal projects. Eventually we assembled a big team. I think it was quite big. Pretty much like a team we would hand out to a client, and started working on sort of like an application that we would want to put into production. And we worked on this for, I think, half a year at least. And then we decided to hand this over to the project manager, who decided to go on working with this on his own, because the project became so big that we couldn't just think about this as a free work for someone anymore. But after that, until this beginning of this year, I hadn't done any more Flutter development, and I had a little bit of a gap or a break from that. And overall, my software development experience is about 4 years. And all this time I've been working in Mooncascade. I started in 2021, June 28th, as an intern. And I was picked up straight from university by Kellyan, who is also going to be presenting. And yeah, that I even didn't finish my master's degree. I've been working here. It's been so interesting. But otherwise, other than mobile development, I have also done some stuff in university every year. For the past 6 years, I think, I've been giving practice sessions in compilers course. So I also am a big fan of just programming languages in general. And now about this mystery application. Well, there was a change recently that originally I didn't plan to talk about the application really. Didn't plan to mention who the client is. I just thought maybe I can give you some technical details about some approaches we took. But there was recently a change that we finally got the reference from the client, and we can just publicly say who it is and give you some details about it. So this is the big bank application. And I'm going to give you a little demo as well about what it looks like in staging environment. So all the details you see will be just staging specific. But yeah, we started this application. Actually, the development really began in February. 30 of January this year is actually Friday, so we just had on client side someone start the repository for all the code we have, and then came the weekend, and the next week after that we started developing. So really we started from February, but we already had silent launches in June this year. And there's multiple of them because the application is for multiple regions. It's a single application, but it was like made accessible to users in different regions. And since it is in different regions, it also has multiple languages. In our case, it's specifically 5 languages right now. And since this is a Flutter event and I'm talking about this application, you may guess that this is a Flutter application. And last year, in September, there was another presenter from Lightyear talking about their Flutter application. Well, when the client came to us with this application request, then they sort of referred to Lightyear having a Flutter application. So we also got to do a Flutter application now. And one more thing about this application is, I would say there is they already had a web front, so some of the backend development was already like done, and we had quite smooth sort of beginning of the development, which is not always the case if the backend is also being simultaneously like started from scratch. But yeah, just to clarify, the whole application was from scratch. And I will also now maybe give you a little demo of what the application looks like. So started off from the login screen. I have put some mock data over here, faked what the information really is for logging in. And I'll just log straight in. And maybe it would be a good idea to make the size a bit bigger, but you can, if you want some details, you can probably check the recording or just come a bit closer. So right after the login, I landed into the dashboard, which is where the users can see their accounts, their credit cards, deposits, and also loans. As you can see, my test user doesn't have any loans. And last time there was a presentation about scrollable lists or long lists or lazy lists, and how to make them perform well. Well, I had a question about how to optimize a list that is within sort of like a card element. Well, you can see that list here. And fortunately, well, this is a debug build, so you can expect maybe some slowdowns occasionally, but this doesn't really have much to do with the list itself. But the list itself does have quite a bit of content, and it doesn't really have any performance issues, even though I don't think I have taken too many steps to make it very performant. So Flutter out of the box seemingly does most of the stuff itself. And the user can do multiple things in this application other than just see their accounts and credit cards. They can also start payments. The thing is that when we started this application, a lot of the features were just put into like sort of a queue. We began with the most important features, implemented these, and the rest of them remained in web views. So if I were to click on any of those buttons here, they would take me to a web view, and I would be able to sort of continue, for example, my payments over there. But gradually, over time, all these features are planned to be implemented in the application. But, well, not all of them. Some of them are going to remain in the web views. For example, if you... okay, it's the fun thing. We have the company policy of the device, the computer going into lock after not being touched for a while. So this seems to go into effect here. But when I go to the more menu screen, then, for example, you can see some links here that are most definitely not going to be planned to be in-app views. For example, legal documents and policies, and bank contracts are most likely some of those. And we also have cards view, where you can see cards. There are more features coming with this specific view. Yeah. One of the interesting things I just noticed is that the rendering, okay, there we go. There seems to be some interesting stuff with the screen sharing. But yeah, maybe this is enough of an overview with the application. I mean, I didn't mention, but we do have push notifications as well. And well, actually, since this is a debug build, I can also show you that we have a debug menu inside debug builds, where we can do interesting things such as toggle features on and off, and also have some demo screens. But yeah, just some illustrations about what I'll be talking about later. So moving on to the development team that we have, which is a very important thing if you're developing an application. You can't really develop one without a reliable team. So In total, I think the most developers we had at any point in time is 5 developers, and I'm talking about specifically people who are touching the code, the Flutter code. So we had me, an Android developer, we had Ilke, an iOS developer, but at some later point, I think it was about a month in, we had another Android developer join in who was coming from the client side. So they had just hired another developer for themselves. And this time specifically an Android developer, because previously they didn't have any mobile developers. But we also had 2 other developers who were full stack. And they really joined the development because they were interested. So they originally didn't have any plan of staying in the project. They were just curious about how Flutter development works, how it looks like. And eventually one of the full stack developers left the project because they stayed in the company, in Bigbank, but they just switched to another project. And then they left that project. But at the same time, the new Android developer on the client side became a tech lead. So as you can see, he even has multiple hands on this picture now. But he is now a bit less involved with development and more with doing some more higher level decisions regarding development. And this is sort of the reflection of the situation we have right now. And maybe I'll now get a bit more technical with the architecture and approaches we have taken. So since this is a client application, client came to us with a situation where they don't have their own development team, but they want to have a banking application. Well, if it's a banking application, most likely they want to have this for quite a long while. This isn't something that they just develop and then throw away. It's not an MVP. It's something that they plan to keep on using. And with that in mind, well, we have to make an application that the client can eventually take over. They can continue to maintain. They can apply their own team to it. And yeah, they can just keep maintaining it for as long as, well, this application still applies for their business needs. So with that in mind, we have to think about it. The application must so how do we make the application remain maintainable and make it so that the application can be picked up by another team or new people? In most cases, the thing that you can think about immediately is what are the most popular, or what are the popular approaches, or what are the official guidelines for developing applications. And if you apply those, then most likely the client won't have a problem hiring people, because if these are like sort of mainstream approaches or guidelines, then it's more likely that more people are aware of these things. And if you maybe even do hiring, you can already shout out what you're looking for. And so if this is a popular thing, then most likely people will know it. And they can already, based on that, try to apply to the job. And one other thing that we thought about, if the application must remain alive for a long time, then maybe a good thing would be to not use third-party libraries, because quite often third-party libraries are maintained by just maybe a few people at best. Sometimes it's just a single one that actively develops it or maintains it. And very often the security part about third-party libraries is also kind of questionable. And specifically, since this is a banking application, all of the libraries that we are using need to be validated somehow. So we cannot just randomly slap some library into the application and think that it's going to save our day. We have to validate it as well. So in this case, most reliable source of libraries and dependencies would be some first parties such as Google or the Flutter team. Fortunately, with Flutter, we have a lot of such libraries available to us. But at the same time, I think compared to native development, Flutter has way more third-party libraries that basically a lot of functionality is actually still outsourced to third-party libraries that you need to use. For example, accurate number representations. If you want to not use third-party libraries, you're going to probably have to use strings. What can you do with strings? Well, you can maybe only compare, but maybe only to some extent. or just pass them around. But if you want to do some computations, then you're going to have to start using a third-party library because Flutter out of the box doesn't have one. Another philosophical point that we have followed is that we don't do any just-in-case abstractions. We don't leave dead code into the code base. These two things are very important if you want to remain maintainable. I mean, dead code is just going to float around. You're going to be maintaining it even if it's still in the code base, but nothing is using it. And abstractions are just going to make things confusing if you are not prepared for those things. In fact, with this application, we have been really steering away from doing abstractions if we're not waiting for them. Usually with abstractions, we want to have some sort of proof that we really need them. And generally, it's just having a lot of examples how you would use something is already like good enough proof or inspiration for how you want to abstract things. And most importantly, you have to stay consistent. Otherwise, well, if you don't stay consistent, then things are going to start falling apart. And consistency also helps you onboard new people, so they don't have to go through, I don't know, 100 different styles of writing something. They can probably just see 5 different ones that are there for necessity, and they can go on with that. So regarding official guidelines, Google fortunately has, or let's say specifically Flutter team has documented an official guide for architecture, which is quite fortunate because not every platform that you might be working with has this. For example, in web, you have lots of different approaches, and I don't think you can really consider any of them official unless you're talking in the specific framework. And I think in iOS as well, there's quite a lot of discussions about what are the official approaches and things, because Apple doesn't really describe them very often, or at least this has been what I've heard. But last year I was working on an Android application, a native application, and when I started working on the Flutter application, I was quite surprised when I saw that such architecture is described in the documentation, because this is very identical to what native Android actually also has. But the difference with the native Android architecture is that the Flutter team doesn't really provide any specific tooling to implement these things. It only provides high-level documentation and lists some options. For example, for view model, you could use block, you could use some other state management. I think there was Riverboat, for example, and you could maybe even implement this by hand, which is what we did. And we took this architecture guideline and changed it around a bit, got a bit more specific. So previously you saw that there was view instead of screen, for example. We decided we were not going to make any view-specific view models. We're going to have screen-specific view models. And we kept the domain layer, which has use cases. And with the data layer, we decided instead of having general services, we're going to start having APIs and local storages. But the most important thing is that we still have 3 layers, which is the UI, domain, and data. And as you can see from the illustration as well, the use cases are sometimes optional. We don't use them if they're not necessary, but if they are actually helpful, useful, then we do apply them. But this is not it. This is not all of it. We also added 2 other modules to this architecture. One of them is core, which contains language extensions. Well, if you're coming from different languages, you might be missing something if you switch to Dart. Fortunately, there isn't many of the language extensions that we had to do, but there are maybe some simple things on strings, for example. And inside this core module, we also have platform channels, which we use to communicate with the native platform. Really just a place to declare these sorts of APIs with the native platform. And we went with the approach that this native platforms and core like language extensions could be accessible from anywhere. You don't have to be necessarily inside data or UI to use platform channels. And this is not sort of like a final decision. this might be changed. Usually we don't apply to many of the platform channels inside use cases, for example, or view models. But yeah, we didn't think it was a very good idea to restrict it too much. And we also have a debug module which just contains all of the debug code which we don't want to ship with the release builds. Having it separately like that helps us also validate if we do look into the release build contents, if any of the debug build paths are visible. And also it's a good place to put them, because if you do any testing, you can also sort of exclude the test coverage from those files, because you don't want to waste your time adding test coverage to those things. But the tech stack itself, I would say we don't use, like, since we don't have a lot of third-party libraries, we don't also have a lot of libraries in total. We do use Provider for dependency injection. We do use CoRouter for navigation. We have Eric-Start for streams, which are quite important for our architecture. And one other very important thing is Freest library. So you might be maybe familiar with Equitable library. Well, with Freest, things get even more simpler, but you do have to deal with code generation, which can get quite tedious at times. But the idea is that you don't have to declare anything other than just a constructor and a class to get the data class. So since last year I was working with Kotlin. Kotlin has data classes, so I didn't have to do any of that over there. Really missed it when I switched to Flutter, so decided we would start using the Freest library. And then there are some other libraries, for example, HTTP, which is first party, shared preferences, first party. I think maybe the only one out of these listed here, I think Freest library and Decimal. Sorry, I think only Decimal here is not first party. Even Freest is first party. And we have some other like sort of language feature specific libraries such as collection, and I think there was async library as well that we were using. And maybe another noteworthy thing is that we were using Intel library, which is used for translations basically. And we didn't actually even look into do many options when we decided on this. We just saw that it does code generation. It's quite comfortable to use, so we went with that. But recently I've been looking into these other options, and I'm actually quite glad that we picked this, because the other ones don't feel very comfortable to use. So now I'll maybe also give like a look through the different architectural like components that I listed before, starting with the screens and widgets. So each screen that we have is usually a stateful widget, and this is just so that we can have some state inside screens as well if it is necessary. If it is not business related, we can keep it there. For example, you might think about scroll controllers or text field controllers. We try to keep these out of the view model because it is very like specific to declaring a UI, like the structure and so on. And all the state that we have is usually contained inside a view model. And this is just referenced inside the stateful widget itself. But the contents of the state, the widget state basically, this will then just declare the build methods and also some other helper methods that we use for event handling. You might, I don't really know what is the most widespread approach to declaring UIs in Flutter. If it is just to dump everything into a build method and then nest it deeply. And I don't know how readable this will become, most likely not very readable, but the approach we took is that we would have helper methods which begin with _build, and this would always return a widget or a nullable widget. And this became sort of an approach where we are able to declare the screen itself inside the same widget. And if we wanted to really separate something, some content of the screen into a separate widget, then we can still do it. But we don't have to dump everything into a single widget, sorry, a single build method. And it helps helps with reducing the nesting quite a lot. And we still get the like benefit of accessing the view model from these methods. But yeah, it doesn't mean that we don't use sub-widgets. Most often we have sub-widgets for sort of design system components, such as, for example, buttons. And we have even made widgets for something such as a scaffold, because for the longest time we were just using the scaffold that is coming from the material team directly, but we added all sorts of padding, all sorts of surrounding safer areas and stuff into that. So the nesting became pretty crazy. And we just decided, hey, we're going to reduce this nesting by implementing this sort of a my scaffold element. And fortunately, in Flutter, this actually was quite comfortable to declare inside, as compared to maybe native Android development, where you also have declarative UI. But doing a scaffold component can be a bit different there, because there are different kinds of bodies you would have. But our scaffold basically has an app bar, a body, and a bottom bar, which is what we use for holding CTAs, which are sticky to the bottom of the screen. And there isn't too much like variation between the screens either. So this sort of a component was feasible to make. And maybe I'll come back to how we have been using the design system itself a bit later, but you can see some sort of a preview of that, how we have attached our design system to the context, and we basically just read different styles out of that, and we also read string values from the context, and also colors and typography would come from there. But I also mentioned event handling. So the screen itself gets state from the view model, but just a single state is not really sufficient to really handle everything that should be coming from the view model. For example, we are doing navigations inside the screen widget. We don't pass any sort of context to the view model. We don't pass any routers to the view model. We do this sort of navigation stuff inside the screen widget. And to handle navigation events, we would have to basically handle these state changes separately. We cannot do this in build, because build can run whenever. But if we just handle the event separately, listening to what are the changes from the view model, then we can handle the events nicely. It just is that we get the event from the view model, we tell the view model that we have handled it, and then the event is cleared. But before we let the view model know about that, we can just trigger the navigation from here. And we have been using basic named routes throughout the application so far. And yeah, we can move on to the view model. I feel like the screen is a bit dark. Could it be?
It's just getting darker and darker, right?
Yeah, it's a bit funny. Maybe someone wants to look into that. But yeah. Could it be something to do with the HDMI, or I don't know?
Settings, maybe?
I think it's a TV setting.
Yeah, I would also
It's
think
just
so.
it's after 7 o'clock now. It's time to
Yeah. Maybe we should turn off the lights or something. It will.
It's scary.
Well, Halloween themed presentation.
Shit. Out of options. Yeah.
It's getting suddenly much more darker now. I don't know what's happening.
Depends on the amount of white that is displayed on the screen. On the previous slide, you had more text.
Mm-hmm.
So it kind of tries to auto-balance.
Yeah, it does that, yeah. That's interesting because...
Is it better? Or?
No, it's not, I think.
Okay.
Or... No, it's a bit
Yeah,
better.
there was also a brightness option.
Oh, yeah, it should be. Let me check.
So we invited you here today to fix this TV. There we go. That's something
Make me
useful.
stop. Okay.
No, keep going.
Okay, wow.
At least it's visible, huh? I hope.
Okay.
Can you check the echo settings?
Yeah, I think that sounds like the right thing.
It just resets.
Which one? No,
Oh.
go back.
Go west.
Yeah.
Okay.
All settings and
Yep.
the fourth.
Which one? All settings?
Yeah.
Any questions so far? I've been yapping about the details about the architecture.
All the states are in the model view, right?
Sorry?
All the states are in model view.
View model, yes.
Yeah.
But it's not all the base state, it's specific to the screen that is there. But the overall application state is passing through view model, yes.
Okay, so let's say scenario, I'm on a login screen and I turn off the internet, then I log in. It takes me to another screen and there's a try again button. I click on it. What
Yeah,
should happen?
perfect.
Should I
Thank you.
go back to the original screen and the try again, or should the try again be on the same screen and the view model architecture?
So that now depends how your error handling works, right? So we have with general errors, we do have global errors, global error handling. I haven't described it here today because it's still not something that we consider final and it's moving about all the time. But one option for that is that you would actually have separate global error handling screen for that. But in our case, now it depends on which stage this error happens. The login flow we have is actually like multiple stages. Since we're in Estonia and in Baltics, we have smart IDs and mobile IDs and stuff. So this involves signing and stuff. In such scenarios, we're still actually forced to start the login flow over from the very beginning if something goes wrong with verification. So there's just two stages where you start the login and then you have to verify as well with the smart ID or mobile ID. In such scenarios, we do navigate back to login screen. But I think that really depends on maybe some other requirements. It's not like impossible to have the same thing that we would retry it on the loading screen. I will get to the point which might actually make this much more simpler eventually as well. But okay, we finally have a bright screen. Everyone can see it now, yes? If there is anything else wrong with the screen that I don't notice, then you can also let me know. It's a good thing that I mentioned it right now. But coming back to the view model, so for view models, for the longest time, we were using change notifier directly to declare them. So change notifier is something that you get pretty much out of the box. It is able to notify your widgets if there's something like changed, something was updated. For example, in the UI code, we were using listenable builder to keep track of the state changes. So every time there would be a change, some changes, not like the UI is notified of a change, then we would be rebuilding. And eventually we got around to actually declaring an abstract class for the view model, which itself contains all the logic necessary to abstract away change notifier. So we had tons of screen where we were using change notifier directly until we finally did it, because at that point we had enough examples of how we want to do it. What exactly do we need for the view model? And then we went ahead and did it. And ever since then, we haven't really had any major changes to this view model because it has been exactly how we needed it from the get-go. But this view model then, as I showed in this illustration before, is interacting with repositories and use cases. And the screen itself doesn't have any knowledge about what are the repositories, what are the use cases being used, where's the data coming from. The view model sort of makes some decisions on that. And the overall structure is pretty much just like this. We would have a constructor. We would be injecting some fields here through the constructor. And these fields would be containing these repositories and use cases. We would have view model state, which are like private fields where we basically can hold some state, which view model knows about, but these states are being used and to like derive UI state. And this, I call it UI state because it is specific to what the UI should be showing For example, if some button should be visible, it is not saying some like, I don't know, domain level, like it isn't using domain level naming, it is using specifically for the UI, is a button visible, or what is the state of the button, or if maybe something is enabled or disabled. And within this view model, we also have an it method where we do some work. For example, we start observing different values that are coming from either use cases or repositories. And very normal, like usually what we have is that when we open up a screen, we also refresh the content it should be showing. So for example, we would be refreshing what is the user details when we navigate to a screen. And with this approach, maybe I'll also talk about this separately, but we have this sort of an approach where we observe and refresh. Yep, and the states that I mentioned, so the screen state is separate from the view model states. The screen state is usually public fields, but the view model states are private, and the view model states usually they have a bit more raw representation of the data, and it is not specific to what the UI terminology would be like. Usually, like the UI state fields would be already like filtered lists. For example, I don't know. Let's say you have a list of transactions you want to show. You would keep that in a UI state. But there's a whole list of transactions, maybe something that you did not like search for, that would be a view model state. Maybe I can word it a bit better, is that if you were to search for transactions, then the search keyword would be applied to the UI state like field for the transactions, and the whole list of transactions would be a view model state field. And the other thing that you saw at the bottom here is that we have UI events and then the observe methods. So with UI events, we have separate methods which convey what has happened in the UI. So if a user clicks on a refresh button or clicks on an account or wants to pay, they click on a pay button, then we have separate methods for these things. If the user clicks on account, then we handle it here that even the naming is like as if it was an event that is coming from the UI, and the method the names do not indicate what exactly should happen, because that is up to the view model to decide what exactly should be done in such a case. So for example, we don't name the method navigate to account view. We have the view model decide what exactly happens. So the view model decides, okay, I'll do the navigation and I'll update the state. And the only way the UI will know about this is if it gets the UI state corresponding to the navigation event. And yeah, all these event methods themselves are like either void, return type, or they have a future void. So we don't return any information through them. And the other methods that we have here are observe methods. So the approach that we have here is in the view model, we start observing data. And whenever there would be any updates to that data, we would be immediately able to receive them and update the UI. So let's say, for example, you do navigate to an account view, you do some changes over there, and you navigate back to the, let's say, home screen, then all these updates that you did, all those changes will already be reflected on the home screen. You don't have to do any additional, hey, let's refresh these things, give me the latest information. You can always miss this if you have to do this by hand. But if you do start observing these values, then you don't have to always keep refreshing them manually here. So that is like one of the benefits of using this sort of observe and refresh separation. There's probably a better terminology for this. I'm pretty sure someone has thought about the name, and I might have just forgotten about it if I've heard of it. And also maybe it's a good place to mention that we don't do any sort of caching with duration. So if maybe last year there was this presentation about Lightyear, they were using, I think this is quite common actually, and I've been in such projects as well, where network calls are being done, but then these like responses are being cached for a few seconds, let's say about like 3 or 10 seconds or maybe even an hour sometimes. We don't do that. Personally, I find it quite annoying if I scroll Instagram and then I try to refresh the content. It doesn't refresh, although it does show me that it did refresh. The content doesn't change because it probably does cache everything. So yeah, we don't do this sort of caching. We just rely on these refresh calls. And when you start observing things, we don't. The observe really is just observing. It doesn't trigger any refreshes itself. But moving on to use cases, so there was a mention of this login behavior that if you do get an error, what should happen if you try again? Should it navigate back to the login screen, or should it do the retry right from where it was? Well, use cases is sometimes a thing that you could use for this, but it doesn't apply every time. But there are mostly cases where you can still use them. Use cases themselves are just another way of containing some useful logic that you want to reuse. Is it either some logic that you would be using in multiple view models, or is it something that you just have to move out from a repository, which use cases is usually also using? Or I think most often what you have is that you have multiple repositories providing different bits of logic, but you want to combine that logic into a single place, then use cases would be a nice place to do that. My experience is that use cases should not be mandatory to use, and this is also thankfully reflected in the Flutter official guideline, that they are very optional. In most cases, people don't even use them at all. But my experience is that I've been in projects where use cases are used as a rule of thumb, and these use cases are pretty much as simple as what you can see on this image, that it just is accessing a single field from what the return value from repository has. Not a very useful use case, would it be, right? So these sorts of simple use cases we don't use at all. Try to avoid them, because it's really just another layer of code to look through to get to the logic that you might be interested in without any benefits. And we also get to repositories. Now, repositories, I think in our application, is one of the most heaviest part of logic. We have most of the business logic happening over there. This way we do get reusability in different view models. And we have been quite fortunate that we don't even have to, in most cases, abstract the logic away into use cases. One thing I didn't mention with use cases, you don't actually even have to use repositories here. It can also be some validation logic that you do here. But then you wouldn't maybe want to even put into repositories, because that is not interacting with anything such as APIs or storage. But the repositories do interact with APIs and the local storages. Very often what we have happening is, since we have streams of data, we are sort of declaring these streams inside local storage. So local storage is sort of the place which controls these streams. And inside repositories, we do the network calls, but the results of those calls are being then forwarded to the local storage. And this is the way we sort of get the stream, as you can see here. And like, this is a very simple case of a method inside the repository, but what we have most often is that the repository method contains multiple steps of network calls. And the reason for that is that we are not in control of the backend. Big bank developers themselves are actually developing the backend. And since the backend was around before the application, we were not there to tell them what the backend should be like for the application to be most efficient. So there is actually some work that the application is doing on the front-end side. So there is some work that the application is doing for the backend, such as combining different bits of data. And most definitely, we're not doing validation there without the backend doing it. So yeah, we do have to put quite a bit of logic here. I think last year, the Lightyear application, for example, was a lot simpler. they only had to do like simple fetches here, which would automatically be cached inside storages. But that's not as simple for us because, well, it seemed like Lightyear doesn't have to do such heavy logic on the front-end side. But this heavy logic hasn't really been a showstopper for us. We've managed it with this approach, and well, yeah. Especially it's fortunate because we're using Flutter. We don't have to declare it twice on different platforms. And maybe also some examples about the API and local storage. So with the API, we don't use any fancy different libraries that might be handling the responses for you. We are using the HTTP library, and we have also wrapped it inside the my HTTP client. I didn't mention this, but the my prefix is because it's a mystery application. In the actual application, we use a different prefix. But it sounded funny that I can just call everything my as if it's out of documentation. But for each of the endpoints we have, there is a single method for it. And we even like, for each of the endpoints, we also handle the responses as separate types. Usually it is some sort of result type, but most often what we have is that we are only interested in either the success case or if something went wrong. And in such cases, we have this interesting option type. Can I zoom in? No, I cannot. Oh, well. We have option type, which is able to hold either a specific value, or if we get nothing back from the option, then that basically corresponds to an error. I'll also give you a look inside the type later on. But we really heavily rely on either enums or sealed classes. So this helps us avoid handling some excessive cases. I don't know, maybe in Java world you're familiar with having to write default cases for every switch that you write. Well, with sealed classes, which is also now available in Java, you don't actually have to do it. I think actually sealed classes released in Flutter after, in Dart after Java, but oh well.
How do you call it?
Sealed classes. So it's also written there. But yeah, the idea of the sealed class is that it's already like, it's pretty much the same as abstract class, but it is compiled in a way that the code already knows that you have handled all the different subclasses of the sealed type. So there is no surprises, no new types with that. And it's very similar to enums, where you also have fixed number of different values, not types, different values. And the responses, we actually handle them by hand. There was a point where we tried to declare sort of like automatic parsing of the response, but again, we were not there to implement the backend or guide or influence the backend that much that we could have responses exactly as we needed them. So there are some funny cases where the response is quite similar to different cases, but there are minor differences, and we were not able to reliably or comfortably use some sort of automatic parsing of those responses. And moving on to local storage. The local storages are usually quite simple. So we do have basically a behavior subject here that we use to create the streams, and we hold the values there as well. And these behavior subjects are being pretty much passed as a stream. And whenever there would be like an update, we just update the value with this sort of value field of the behavior subject. And if we do that, then this already pretty much notifies the stream that an update has occurred, and so maybe something should be updated in the UI or wherever we're listening. And there is no example of that here, but if we were to want to persist data, then we would be using shared preferences for that. But most of the data that we have in the application, it is not persisted. I mean, it doesn't make sense to do it because, first of all, the application is online only. And the only details that we might have is maybe user settings or maybe some, I don't think we don't even store biometrics details with the local storage. It's all coming from native platform, which is also a very important thing when you do biometric login authentication. And then there were those two other modules that we had, core and debug. Well, I don't think there's much to talk about debug because that is really just some debug code that maybe you shouldn't even be seeing or knowing about. But with the core module, we have language extensions, as I mentioned before. These are usually just some simple stuff that you might be missing from other languages. For example, if I were to come to Tart from Kotlin, then Kotlin had nice scope functions. I don't suggest you do that, but if you're learning Flutter, then it's actually coming from Kotlin. It was like, I need to have them again, so one would declare them here. Or if you want to make your code a bit safer, there is no safe casting in Dart, not yet at least. So let's say you want to cast a random type into an integer. Well, it turns out it's not actually an integer, or it cannot be cast. Your code would throw an exception. Well, we don't want that, so what we could do is write an extension here for any type and try to do the casting here. And if the casting fails, we just return a null. So it isn't really the best thing to do at all times, but it's an option. It's the place where you would declare such things. And it makes sense to keep it available to all parts of code in such cases. So these are all just utilities that are not really related to specific business stuff. It's really just language features that would benefit the code base. And we also have this different option and result types here. Specifically these two things. It's that funny monad thing that you might be hearing about being some sort of a meme. But we do have them here, and they are pretty much very simple seal classes. So they have two cases. In case of the option, we have that either it has a value or it doesn't. And in case of the result, we have either it has a OK value or it has an error that it's holding. But it doesn't specifically even have to be an error. It can be some other value that you just provide to it. It's just generic. But one reason you might even want to have this option to begin with is that if you have nullability, then if you nest nullability, then that sort of nesting of nullability disappears. And quite often we have that either some value is nullable, and we really do use nullable values as a representation of maybe some value is missing, but that doesn't mean it's like illegal that it's missing. Maybe it's unknown, and that we consider a null value. Then if you want to also represent that we got either a successful or a failure result, then if we want to use nullability for that as well, then that's not going to really work out. And the other thing that we have here is the platform channels. There needs to be a place where we declare them consistently, and we decided that we're not going to put too much thought into that anymore. We're just going to declare them as core module components. And our sort of platform channel API looks something like this, where we would have a method that we want to call. We call method, and this would be nested inside of a catching method. And this itself takes care of that. We don't pass any sort of exceptions on to the rest of the code base if something were to happen from the native code. But maybe, I don't know, there isn't much else to talk about here. It's just things to make the platform channel usage comfortable. So if you're interested in this idea of how to implement this, then you can maybe take a look at it from the recording. And something more about the result types. So the API endpoints that I showed, some of them actually had some case-specific result types, and we use them quite a lot. And the sort of benefit of doing that is that we avoid all sorts of exception throwing, because this is something that is not checked by the compiler. Nothing is going to make sure that you didn't miss an exception that was thrown. Then instead of throwing any sort of exceptions, we just decided we're not going to be throwing them. We're going to be using sealed classes and enum types to represent different bits of data, or outcomes of operations. And this has actually been quite useful, because this helps us make sure that everything is covered. Pretty much just not only just when we're writing code, but also when we're writing tests. Because in tests, it's also that you might be thinking that I need to cover like error cases. Well, what could that be? Well, in our case, it's just another like value that comes from the return. But if you don't have that, then you might be checking for exceptions everywhere and making sure that if you throw an exception from one bit of code, then it doesn't crash the application. So that becomes quite tedious to do. And yeah, just another glimpse at the overview of the application. In general, you might be thinking that I don't know. Some people think that it's too many like different layers that we have, or like in general, like this sort of an architecture has too many layers. But the idea is that when you start implementing a feature, then you would actually just start from the UI. And at that point, you don't even need to think about where the data is coming from. You have the requirements listed to you inside the ticket that you might be doing. And you can just start from maybe implementing the design. You have the design implemented. You know what you need from the view model. And if you implement the view model, you already have a knowledge of what you need from the repository. And when you get to this repository or use case part, then it's also already quite clear what you need from the API and local storage. So when you might say it's too much work to do at once, well, you don't have to do it at once. You can just do it bit by bit. And I'll also give you a good quick overview of the design system that we have. I think we're running out of time. Some pizzas are going cold. So BigBank had their own design system already in place. They are already using it in the web. And well, we had to also implement the similar design system. But well, in some bits, like in one way, it's good that they had a design system in place. But then again, this is a design system that does not apply directly to the mobile application. So in this case, we had to go back and forth with the designer and ask for adjustments or maybe different fonts and have them account for different like contrasts and stuff. Because in case of mobile development, recently there has been like more regulations on accessibility, for example. But overall, the design system, having a design system actually is a pretty good place where you can start doing abstractions. For example, UI elements are pretty good. UI components, are a pretty good abstraction. For example, buttons and maybe different styles of text. Also, yeah, different types of buttons or sort of like slider elements or switches. And one way you could do them is, of course, you can declare widgets. But if you want to have sort of colors and typography and styles available to the whole application you have, and you want to maybe even be flexible that you have multiple themes, dark theme and light theme, then what we took as an approach here is that we made this design system a part of the theme that Flutter is using, and we basically just did it as an extension. So if you have ever declared the theme in Flutter, you might have noticed there is not only just theme data, there is theme data for light and dark modes, and they also have this sort of extensions field where you can provide different extensions. So this is what we did. We declared our own types for this. For example, my theme is one of them. Extended the theme extensions type, and with this, pretty much everything else that we had to do was also like quite clear. We had to implement the copy with method. Unfortunately, this has to be done manually. You cannot use freeze library for this. At least we were not able to. And you also have to implement a interpolation method called lerp, which will allow you to just smoothly transition between different themes. So if you're actually switching from light to dark mode or back and forth, then you're going to be using this lerp. The lerp method is going to be used to make this transition smooth. So a little example of that method is here. But overall, this sort of an approach is really, other than that, it doesn't like look any different from the regular way you would provide the theme. it's just an extension to the existing theme maybe, and you provide it as you would provide any regular Flutter theme to this material app. If you're using material app, maybe you're using something else equivalent. And if you want to make your like theme even more comfortable to use, like we have done, then you can make additional extensions to this build context. Otherwise, you would be using this theme off and provide the context there to access the theme data, and then also ask for the specific extension. But we don't want to do this, so we made an extension for that on the build context. And also, yeah, coming back to this example of how we use the theme, we just ask the context for a style, and we get all this information from there already with the specific styles, maybe for buttons and whatnot. But overall, this is a better alternative than to trying to sort of shoehorn your design system into existing material theme, which has quite limited fields for colors and typographical styles. So if you want to have freedom, then this is one of the ways to go with the implementation. And it's also, I think, quite standard. We didn't even have to follow any official documentation on this, but it's pretty much right out there. And maybe I'll also give now final words so we can finally go and eat. So with Flutter, well, it was fortunately a pretty good choice for Big Bank, because we don't actually have to do a whole lot of tricky native platform communications. So there were very specific ones that we do have to do, sort of like notifications, biometric login. I think maybe there was also the shaking effect. Sorry, not shaking, the debug menu opening, which we only use for the debug builds anyways. But yeah, banking applications usually are quite like simple in a way. They don't really rely on some complicated native platform functionality. So, and also the design system that we had was also gonna be pretty much the same for both platforms. There is no difference in the appearance of things, and this was expected. If you were to maybe have to do specific platform stuff, then maybe it would be a bit more trickier with Flutter. And I would also suggest to be careful with dependencies. As I mentioned before, don't want to step into this bucket where you're gonna be unable to release a new build because maybe there is a security issue with one that you're using, with the dependency that you're using, or it's not supported anymore. You know, Flutter updates happen quite often. If something is no longer maintained, you're gonna be stuck on an old version maybe. And we were actually quite successful. We were quite swift with developing this application, even though we didn't try to reduce a lot of like duplicate code. And this was purposefully done so that we would get some more sort of examples of what we were dealing with and how would be the best way to sort of introduce abstractions. So I think this application is pretty much a good proof that you're able to move quite fast, even if you do have a lot of duplicate code. This duplicate code is not really gonna slow you down if it's if it's still under control, of course. And maybe on the contrary side, unnecessary abstractions you might start introducing too early on. These would start slowing you down. And yeah, follow official guidelines if possible. I would say this again depends on applications, but in our case, simple application, as banking applications usually are, official guidelines work pretty well. And I mean, it also goes with some broader decisions that might happen when you're first deciding on what the user experience would be like. But these official guidelines are quite flexible and they worked out pretty well for us. And I would also have to mention that teamwork is quite important, because I don't think this application would have gone so well if the whole team wouldn't have been on this whole thing regarding the code base, regarding the business decisions, giving out advice to the people that are not so tech savvy, and really being team players. I didn't mention even that we had QAs. I mean, even QAs have been quite big team players, and getting along with them is quite important because otherwise your tickets are not getting through testing. So yeah, these are like important things to move swiftly and get things done. So I would maybe conclude my presentation here.